As I mentioned in the opening, we're attempting to focus on some thoughtful discussions about key technical topics. And as you know, we've always talked about AI as essential to national security, to economic competitiveness, and the broader sort of issues that transform our society. We highlighted that in Vision 2030, although I don't think any of us might have anticipated when that document was written just how transformative generative AI has been and what a change that has created across our society, not yet fully realized, but truly amazing. So we're going to have a panel today of experts, several of whom are old friends of mine and former colleagues from across academia as well as industry to speak about the promise, the challenge, the training and the educational benefits, and some of the policy considerations as we harness AI's potential for good. So let me in advance thank the panelists. We'll thank them again at the end. And I'm going to hand the floor over to Julia, who is going to moderate the panel. Julia?
Yeah, thank you very much, Dan, and good morning, everybody. Welcome to our external engagement panel. When you think about emerging technical areas, I think almost everybody would name AI first. And so it is appropriate that we kick off what I anticipate to be a series with a discussion on AI entitled "The Future is Now, Harnessing AI for Good." But before I start, I'd like to ask the board members once again and others in attendance, please turn off your cameras and mute your microphones during the presentations so that we can focus on the speakers. I'm excited to moderate today's panel, and this, of course, is an emerging and critical technology area. Artificial intelligence is gaining significant attention in our national conversation. You really can hardly open a newspaper or watch the news without seeing some kind of reference or at least impact of it. And that's across academia, the private sector, among policymakers, the education sector, and of course, among the general public. Responsible AI use holds unlimited possibilities for positive impact in numerous areas. And that includes, of course, commerce, navigation, finance, medicine, and science and engineering fields such as agriculture, chemistry, energy, and robotics, among so many others. Irresponsible use, on the other hand, at a minimum, can exacerbate societal inequalities, impact our national security, and stifle innovation. So how we balance expanding opportunities in innovation, supporting basic and applied AI research, and building in beneficial and responsive partnerships with the limitations of AI and the need for managing its malintent use is a defining moment for all of us. I'm really excited by today's panel, who will help us explore these topics, and I'm grateful to them for providing some background information, which I found very illustrative and illuminating. We're joined today by leaders who have been working on AI for decades. Collectively, our panelists have transformed the field. They've been at the leading edge of AI innovation, and they've been involved in policy recommendations at the federal level. They're well poised to answer our questions on the current state of AI, what's coming around the corner, what our nation needs to ensure that our workforce is primed for current and future AI technologies, and other related threads. So I'm going to start by introducing today's guests. Our first panelist is Eric Horvitz, who serves as Microsoft's Chief Scientific Officer. He is known for his contributions to AI theory and practice, and his efforts and collaborations have led to fielded systems in healthcare, transportation, e-commerce, operating systems, and aerospace. Eric is currently serving on the President's Council of Advisors on Science and Technology, PCAST, which just this week released its report, Supercharging Research, Harnessing Artificial Intelligence to Global Challenges. He's a member of the National Academy of Engineering and the American Academy of Arts and Sciences, and has been elected Fellow of AAAI, AAAS, and ACM. Our second panelist is Bart Selman. He is at Cornell University, where he's professor of computer science. He's a past president of AAAI, the main international professional society for AI researchers and practitioners. He was also co-chair of a national study to develop a 20-year roadmap for AI research to guide U.S. government research investments in AI. Ken Forbes is our third panelist. He's the Walter P. Murphy Professor of Computer Science and Professor of Education at Northwestern University. Ken's work has included research on qualitative reasoning, analogical reasoning and learning, spatial reasoning, sketch understanding, natural language understanding, cognitive architecture, reasoning system design, and AI for education and learning. He is a fellow of AAAI, which is the Cognitive Science Society, the Association for Computing Machinery, and AAAS. He's the inaugural recipient of the Herbert A. Simon Prize, a recipient of the Humboldt Research Award, and served as chair of the Cognitive Science Society. And our fourth speaker is Lynne Parker, who is Associate Vice Chancellor at the University of Tennessee, Knoxville, and the director of the AI Tennessee Initiative, which aims to position Tennessee as a national and global leader in the data-intensive knowledge economy. She has served in 3 administrations, including as Deputy Chief Technology Officer of the United States and founding director of the National AI Initiative Office. Lynne led the development of numerous landmark national AI policies, bolstering research, government, education, and workforce training, international engagement, and the federal use of AI. She is an expert on distributed and intelligent robot systems, human-robot interactions, and AI. At the end of the 4 presentations, we will invite board members to turn their cameras back on and start the Q&A. So I encourage you to be thinking of your comments and questions as these various speakers make their remarks. I'm going to turn now to Eric to start his presentation.
Well, good morning, and thank you for the introduction. It's great to be here with you all today. I'd like to provide some top-level comments on the possibilities ahead with leveraging advances in AI to revolutionize scientific discovery across disciplines. Next slide. It's an exciting time for AI research and applications. Now, we had an inflection in AI R&D a little over a decade ago with a fast-moving wave of advances based on training and inference with neural net models. And then we had leaps in diagnosis, image recognition, speech recognition, and many other tasks, surprisingly reaching human parity on challenging benchmarks in vision, reading comprehension, translation, and multiple language tasks. Next slide. But 2 years ago, we hit a new inflection point, which we can view as an inflection upon an inflection, with a jump in qualitative and quantitative capabilities with generative models, showing, at least from my point of view, unexpected and surprising powers of generation, including human-like and in some ways superhuman abilities with composition, generalization, abstraction, summarization, and the ability to reason and generate within and across modalities of language, imagery, and multiple forms of scientific data like protein sequence and structure. These technologies have already come into broad use in a wide array of applications, but I'm particularly excited about the possibilities for harnessing these methods to supercharge scientific discovery. AI is truly poised to revolutionize every scientific discipline and change many facets of how we conduct research. Now, more on details of the possibilities, as just mentioned, for harnessing AI can be found in the report that I co-authored with PCAST colleagues that was just released on Monday, where we detail applications in the life sciences and healthcare, material science, physics, sustainability, and the social and behavioral sciences. Next slide. But for now, I'd like to highlight efforts and possibilities for harnessing large neural models for accelerating discovery via enabling modeling, generation, and simulation at multiple spatial and temporal scales. Neural models are under development for different spatial scales, ranging from atoms to compounds, and from gene expression and protein interactions to cellular networks, from cells to human physiology, and from individuals to populations. Advances include late-breaking efforts on multimodal approaches that integrate diverse forms of information, such as protein structure and sequence, the expression of proteins and RNA, and imagery coupled with spatial configurations of protein. These models promise to provide new capabilities, such as enabling in silico studies of perturbations and interventions on cells that can promise to help with the design of new medications and therapies. And there's much to be done and learned. For example, beyond spatial, we have data and inferences about temporal trajectories of molecules intracellular processes and physiologies. Next slide. Now, beyond single models, we're seeing the development of end-to-end scientific discovery pipelines, along with practices and workflows as compositions of AI methods, sometimes hybrid with other more traditional scientific computing methodologies. Scientific communities are learning how to use and build and use these pipelines. For example, in the material sciences, training and inference workflows are being used to generate and then evaluate vast pools of promising candidates. Next slide. Now, one strategy involves leveraging high-performance computing to generate training data based on principles of physics and chemistry, such as employing well-known functions like Schrodinger's function and DFT, an approximation, to compute instances of quantum chemistry solutions. This data is then utilized to develop neural approximation models capable of operating with orders of magnitude speedups. These speedups then support high throughput evaluation of new candidate materials or therapeutics. We're seeing the exciting development of large science foundation models within scientific areas that can be used for multiple tasks within disciplines. And these can guide, for example, the generation of large numbers of candidate materials, proteins, and therapeutics. Next slide. As an example of an AI-centric discovery pipeline, in a recent cross-organization collaboration, a discovery workflow employing several distinct phases of traditional computations and AI models interleaved were used to generate a promising novel electrolyte candidate solution for a battery, one that requires 70% less lithium than today's lithium batteries. Now, in the approach, first, 32 million potential candidates were composed via brute force approach. Then desired properties, including thermal stability, were considered in a neural model that honed the candidates down to 500,000 stable candidates. Then a second neural model trained to approximate molecular analysis was used to evaluate candidates 1,500 times faster than traditional high-performance computing methods. This model refined the list down to 800 candidates, which were then analyzed via another phase of traditional molecular dynamics, followed up by an AI model, finally revealing a novel electrolyte. This is just one example of what is growing into an AI-powered discovery process and set of best practices and understandings in other areas, such as with the development of new antibiotics, where we have several just as exciting stories right now. Next slide. Now, beyond technical advances, we're going to have to attend to key socio-technical and community considerations to nurture the creative and vibrant use of AI applications in the sciences. These include efforts to ensure that U.S. scientists and engineers across sectors gain access to computing infrastructure, including computational resources, models and tools, and data sets and data hosting. We also need to work on community to explore the sharing and pooling of resources and data on shared scientific goals. Furthermore, empowering our scientists and engineers are going to take updating educational curricula to incorporate AI tools from K through 12 through higher education, with work to seamlessly integrate these tools into academic disciplines. There's no reason to have AI experts and scientific experts in particular disciplines. We need to sort of bolster and supercharge the fields themselves with changing the way the fields work with these opportunities and tools. It's also crucial to maintain scientific integrity with uses of AI applications, with special considerations to assure the veracity of inferences, the replicability of results, tracking the provenance of data used in our systems, including the provenance of synthetic data and its flow through our systems and models, and attribution of sources. Lastly, we have to prioritize issues with safety and responsibility, taking proactive measures against the possible misuse of the rising dual powers of AI with careful efforts in areas like biosecurity. Thanks very much.
Thank you, Eric, for getting us started. I'd now like to turn the floor over to Bart Selman.
Yeah, thank you very much. Thank you for having me. Slides, please. Yeah, I'll give a high-level brief overview, state of AI. Next slide, please. So as Eric already mentioned, we're of course in a very innovative time, starting in my mind actually around 2012 with deep nets, computer vision, machine translation, decision making, natural language models, the large language models that we've seen recently. It's an incredible, exciting progress for AI researchers. If you look at the main artificial intelligence conferences, they now have 10,000 plus submissions, while a decade ago it was about 1,000. So we see an order of magnitude increase in activity. And of course, the large language models are perhaps the most exciting recent advance. I like the comparison, it's sometimes called the telescope for the human mind. So it allows people to think further, scientists to think deeper, make new connections, and I've used it in my own work. They are remarkable new sources of knowledge and collaboration for everybody, including scientists. Next slide, please. We composed actually a roadmap for AI research. This was done by a group of about 100 plus top scientists, top AI researchers, 2018, 2019. And we identified a whole sequence, range of areas from health, lifelong education, business innovation, accelerating scientific discovery, social justice, and policy and cyber defense and security. And in each of these areas, we identified what opportunities there are for AI and how it will impact these fields. In particular, I'd like to focus, of course, for scientific discovery. As Eric mentioned, it is already transforming and accelerating scientific discovery and technology. The next slide, please. So we outlined, it's important to understand that AI research is, although we have these incredible acceleration, there's still challenges, and we characterize them in integrated intelligence, how to bring together different AI capabilities in a single system, meaningful interactions. This is a very important area. How do you interact? How do humans interact with these systems that are becoming increasingly smart and increasingly knowledgeable? So how do we make sure that, how do we get the best interaction, the best collaboration between humans and AI systems? And finally, self-aware learning is an area where the AI system, when they're trained, the large language models, when they're trained, can we have them train and be aware of their own shortcomings, aware of their own limitations? It's also referred to as can we make them trustworthy in terms of learning from data? So these three areas are still central for AI research. Of course, they need to be infused with attention to AI ethics and interpretability. Next slide, please. So this is my concluding slide. There's enormous opportunities here for science and engineering. There's also some real challenges, and I just like to focus here a bit on the challenges. There's clear evidence that the larger the deep neural networks are, with more high quality data, the better they perform. And the current best foundation models, for example, GPT-4, GPT-5, which is now under development, are commercially developed and held, and this is partly needed given the required large investments. However, I think to really stimulate and make use of these models within the science and engineering community around throughout the US, we need some level of sharing these AI research to boost AI for science, engineering, and health. And I'm thinking of something like Science GPT or Engineering GPT. You would actually like to develop such a resource at a national level. This cannot be done purely in academia, and definitely not. It could be done in industry, but one has to think of public-private partnership that would make such a resource available to the science community. And I think there's a very important point. We have a large excellence in scientific discovery and in engineering in the US, boosting that with a foundation model, a large language model, tailored towards science, mathematics, and engineering would boost us ahead. And I'm actually quite convinced that other countries will actually make such resources available to their scientific community. So it's something that would be an amazing opportunity in the US also. So we're at the cusp of a scientific and technological transformation driven by AI. It's a unique nationwide opportunity, assuming we have the proper policy and R&D investments to make this available to our scientific community. Thank you.
Thank you very much, Bart. Now we're going to turn to Ken Forbes. Over to you.
Good morning. So can we show my slides? If my slides are being shown, I don't see them. Should I see them?
Not yet.
Okay, got it.
There you go.
Okay, so next slide, please. There's a lot of hype in AI right now in the popular press. And so let me calibrate what I mean by revolution. By revolution, I mean that there's a technology that's progressed so much that it's in daily use and it's providing significant novel benefits. And by that standard, there's 3 revolutions going on in AI right now. So you've heard about one of them, deep learning, right? So both Eric and Bart have mentioned deep learning, and they've painted a very accurate and clear picture about the benefits, okay? But there's 2 others that don't get as much press, and I think they should, actually. One of them is knowledge graphs. So knowledge graphs are symbolic representations of knowledge that are now at a very large scale. And by very large scale, I mean, for instance, Google's knowledge graph is in the 30 billion fact range. And you're using those every day when you do web search. Amazon has knowledge graphs they use for products and for question answering. Spotify even has a knowledge graph, okay? So they're all over the place in industry now. They're used for a lot of purposes. The third existing revolution is reasoning. So if you drive a Ford car, its electrical system was designed by an automatic system that reasons through the possible things that can go wrong. It's using 6 different levels of models, starting from purely qualitative models to purely quantitative models. And at each stage in the design process, it can tell you exactly what might go wrong with your design in a way that goes far beyond what humans can do. So in some areas, we already have superhuman reasoning, but in general, we don't have anything that's close to human reasoning. Now, the reason we have 3 revolutions going on right now is the same underlying reason. There's been steady scientific progress in all these areas across AI. There's been massive increases in compute, and there's been massive increases in available data. Those rising tides have lifted a number of boats, not just deep learning. So if we have the next slide. So the other thing that's happening, and Bart foreshadowed this in terms of describing how the roadmap was organized, there's a 4th revolution that's coming. And this one, I think, is going to be even bigger because it's built on the fruits of these other 3. So the idea of integrated intelligence is you want things that are beings. You want to have a phase change from software's tool to software's collaborator that interacts with us through natural modalities, that combines perception and reasoning and learning to take action in the world. They have to be data efficient. They have to learn in the same span of examples as people do, because otherwise they're not going to be good collaborators. They have to adapt to us. We can't send our collaborator back to the factory every time new terminology gets introduced or the world changes a little bit. And there's been a number of technologies that have been explored for doing this. They also have to manage their own learning over time. So right now, if you look at the pipelines used for today's AI assistants, they're all manually curated. They use machine learning, but what machine learning happens when, how to get the data together and all that, that's done by humans. And that doesn't scale. Now, the payoffs here are huge. So you could have assistants that actually collaborate with you like humans in your work. You can have lifelong personal assistants that help you with every aspect of your daily life, where if they manage their own learning, you own the data, which is a very important thing for such assistants. Now, leading the way in this are efforts in cognitive architecture, where they've actually studied, based on looking at how humans work, various ways of combining all these capabilities. And in some cases, being very pure in terms of how they do it. In other cases, saying, well, we're going to take great AI components as functional approximations for other pieces. So it's a vibrant area with a lot of interesting work. And over time, you're going to see more and more of these things. Next slide, please. So the key point here is that generative AI is cool, but it's not the only game. And you don't want to neglect the other parts, or you'll never get to that fourth revolution. So large language models and multimodal models are great and they're useful, but they're not going to be cognitive architectures. They are going to be useful components of cognitive architectures if we build them right. But in terms of the number of kinds of memories and the sorts of representations, we already know that they're not going to go the distance as a cognitive architecture. So I have two recommendations based on this. The first is double down on the open knowledge network that NSF is already starting to work on. So the current efforts are interesting, but they're all very applied, and they're all very local to particular applications. And that misses one of the big opportunities here of building an open network that can facilitate all sorts of new activities. So if you also have a complementary effort that focuses on general common sense knowledge and very inferential knowledge, deep reasoning of the kind that commercial knowledge graphs, for instance, don't do today, then you could have a payoff that would multiply across all the different areas that you need knowledge graphs. And the final thing is to invest in more human-like learning methods and reasoning methods. So large language models are great, but if you look at the amount of data they take to learn anything, it's far more than humans need. Far more. And by more, I mean orders of magnitude, millennia of experience rather than a decade or so of experience. And so we're leaving a lot of learning on the table. And you want something that can learn incrementally and learns inspectable models, because otherwise, how do you trust or debug them? So those are my two recommendations. It's an and, not an instead of. Thank you.
Thank you so much, Ken. And last, we are turning to Lynne Parker. Over to you.
Good morning, everyone. I'll pause for a moment while my slides pop up. So having spent the last many years of my career thinking about and working on AI policy, I would like to focus my remarks this morning really to the policy community, the AI policy community. And there's three main messages that I'd like to share with you today. The first one, starting on the next slide, is thinking about and accelerating progress on AI policy goals by making a closer alignment between the AI policy community and the AI R&D community. I think right now, a lot of the work that's being done in the policy space does not leverage the R&D community to the degree that it should. One of the challenges, of course, from the R&D perspective is that there are not measurable policy goals to work toward. They're general policy goals like safe and secure, but what really does that mean? And what are the gaps in the research that can contribute toward achieving the desired level of safe, secure, and trustworthy AI as an example? And so I think what we need to do is to increase the understanding on the policy side of the R&D gaps and to increase the understanding on the R&D side of the areas of policy that are measurable and open for the community to really pursue. So I would like to argue that we focus on more of a roadmap for how to align those goals so that we can accelerate accomplishment of the AI governance policies that I think most of us share. So that's my first message. The second one on the next slide is the intentional active intervention that continues to be needed in the area of expanding geographic participation in AI innovation. This, of course, has been noted by many, including the National Science Board and the Vision 2030 report. But it's clear that the new advances in generative AI are not necessarily having the impact of democratizing participation in AI like many of us thought at the very beginning. A recent report by Brookings shows that nationwide, over 60% of the new generative AI job postings are clustered in the traditional metro areas, just 10 metro areas across the United States. And so what this means is that it's not going to naturally happen that we get broad geographic participation in AI innovation. And so to do this, we need to continue to make active steps to ensuring that we have inclusiveness across the country of those who are able to participate. NSF has been a leader in many of these areas, particularly the National AI Research Institute's program, as well as the National AI Research Resource, or NAIR pilot. But my message here is that we can't let up. I think we have to continue to take these and other steps to make sure that as AI becomes more and more pervasive across society, that we have the participation of people across the country in the innovations that are necessary. And then finally, my third point on the next slide is that we, along the same vein of enabling everyone to participate in the new AI economy, is that we need to focus even more intentionally on broad AI education and workforce training. Certainly, we need more AI experts, deep AI experts across the country, but we also need people in jobs in every economic sector to have enough skills around AI so that they can participate fully in these new jobs. The chart here on the left from the World Economic Forum shows how businesses are continuing to prioritize the adoption of AI technologies and recognize that they need the skills and training for their workforce in AI. And it's happening across all sectors. It's not just the IT sector. And so we certainly recognize that we need to be more intentional about making people, providing people with the opportunities to be AI literate. There are a number of ideas out there for how to accelerate that. One is to build upon NIST's National Initiative for Cybersecurity Education and create a similar sort of framework for AI so that we can outline the knowledge, skills, and abilities that all workers need in their various disciplines in order to fulfill those roles in AI and to have the opportunities to participate in the AI-enabled workforce. So thank you.
Thank you so much, Lynn, and thank you to all of the panelists for covering a very broad waterfront of the promise and challenges of AI as we go forward. Their slides are available in the for board members in the Diligent board book, and a video of the panel presentation will appear shortly on the Science Board's website. Now I'd like to start the Q&A. Board members, please turn on your videos and raise your virtual hands so that we can recognize you in the order in which those hands are raised. Thank you, Dario. We have a question. Dario Gil.
For some reason, I cannot turn my video on. But first, I wanted to thank the panelists for the wonderful remarks. And I want to ask a question regarding the scale of investments and speed of investments required in this notion of a horizontal platform that can serve all the sciences. Both Eric and Bart highlighted the gaps in publicly available data sets, right? Or the need to organize them in a way that can serve all the disciplines, and specifically compute as a gap. My own observation that this is a 4-alarm fire, right, as far as universities is concerned, in that, we've fallen so far behind in the computational capabilities available for universities for AI that, they cannot even reproduce the results, right, being produced in industry, and that's a problem on its own right. Could you address this question of scale? What's the scale of investment that would be required, right, as a shared sort of infrastructure for the university ecosystem in the United States both on data and compute?
Happy to provide a brief answer. There's uncertainty right now in whether we'll be able to do powerful things at smaller scales than have been used to compute the largest language models, for example, that we've computed. So there's uncertainty. We're also very hopeful and interested in waiting to be surprised by the next version of the largest model. So again, we will be getting confirmation over time as to the critical importance of large-scale compute resources. My sense, though, is that that per the task force, the National AI Research National AI Resource Task Force, as well as the pilot, I believe that we need to push Congress to do the appropriations that have been suggested and asked for to as a bare minimum, which has been listed as billions of dollars. That would not be very different than other countries for investments that are being made now. In some ways, the pilot for 2 years seems rather small, given the nature of the opportunity ahead for this nation and what could be done, and the restrictions right now and limitations of resources when it comes to our academic community. I should say that it's not just compute, it's also data. I just came from a large meeting yesterday of folks in AI doing biology, and it was really interesting to hear that they find even when they have terabytes of data available, they have no place to host it, turns out. And hosting it is not trivial. Standards, access, and so on. So I would say it's compute and data resources as well as tools and models that we need to make available.
And if I can jump in and sort of add to Eric's comments, we actually considered this issue very seriously when we composed a roadmap for AI, and it's compute data and actually software engineers to build large language models. It's a combination of resources. Our conclusion was that you need something at the level of the national research labs that we have in applied physics, and we have famous applied physics research labs in the US. You need something at that level, which is indeed a multi-billion-dollar investment. The lab's budgets are in the order of multi-billion dollars. They're currently managed, of course, by the Department of Energy. You need some investment at that level to actually develop these models and make them available. And these are not physical labs, of course, these are distributed labs, but the idea would be to have a distributed center of AI researchers, AI resources combined with the scientists in all the areas, physics, health, medicine, biology, that could really have a high payoff. And as Eric mentioned, there's a lot of talk about this to make this happen. We haven't seen it happen yet. I'm certain that other countries will make this happen for their country, and I think we would miss out if we did not devote those level of resources.
I should point out the same thing is true, for example, for knowledge graphs. So you cannot get your hands for love nor money on the commercial multi-billion fat knowledge graphs. They're just not there. And basically, without an open knowledge network, we're never going to be able to have the body of people doing the research on how to scale these things out and how to scale the reasoning involved over them.
Yeah, and I'll just chime in agreement that I think the billions of dollars of investment is required. As a co-chair of the National AI Resource Task Force and the final report, it's clear that it is the data, it is the computations, it's test beds, it's also educational resources so that people that have not had opportunities to have access to these kinds of resources also have the opportunity to learn how to leverage them once they hopefully become available through a NAIAC implementation. So I do think it's a wide scale investment, but it's clear, I think, that other countries are taking the roadmap really that we have developed in the United States and beginning to make progress on that as well. So we'll get behind from our own roadmap if we don't take action on it.
Thank you all. Next is Roger Beatty.
Yes, thank you very much for the fascinating comments. I'm a biologist, Eric, and I wondered at all of that, wondered at all of the comments as I see the use of protein structure and predictions and actual and chemical development and chemistry that develops to fit receptors and all of the fascinating opportunities that this provides. If we're behind and short in the academic sector for computational biology and skills of using all the available tools or tools that are becoming available, how well prepared are the regulatory agencies for using this knowledge to approve the new antibiotics, to shortcut the regulatory processes to get these solutions that come from AI and from innovation to the public? I'm a plant biologist and I've been just stunned by the paucity of progress in the regulatory activities that affect CRISPR and GM crops and so forth. If we're behind in academics, how far behind are the regulatory agencies?
Well, like my comment on that is that I've been deeply impressed by some of the proactive efforts at the level of executive office, as well as Congress and the agencies to have been jumping in on this. Like we have to refer back to Lynne Parker's, sort of groundbreaking work during her role in a couple of administrations. So I've been overall impressed. I've been engaged directly on some of these issues. That doesn't mean there are many questions and you need to put more attention on some of these questions. For example, there's uncertainty right now when it comes to the FDA's approach to generative AI in delivering healthcare. What's the balance going to be between innovation and risk aversion? And do the regulatory agencies, per your suggestion, Roger, do they have the right understandings and insights about dual use, the incredible possibilities, as well as some of the rough edges to start doing the right kind of balancing for the nation?
I will say that I'm encouraged, I think, by the current push to getting more talent into the federal government, including the regulatory agencies. Certainly, it helps also when experts just lend their expertise even for a year or two. So I think there are different pathways toward getting that kind of expertise in the federal government, including the regulatory agencies. But as with everything, it's going to take proactive participation by the experts, the people who know this area, to be willing to contribute their expertise to the government.
Great, thank you. Suresh Babu.
Thank you, Julia. I have a question to my colleague Lynne and also Ken. I really like this lifelong individualist learning and democratization of AI technology also. Would you consider, while the software is developing in a hardware revolution also, would we all carry a particular device with us, collecting data and learning? How do you envision, because you all have experience looking at future, how would it look like?
Certainly, there have been models for concepts for a long time of sort of carrying around these assistants that gather information as we go, and then their little bug in our ear or a little vision in our eyes that help us as those kind of assistants. I think they're probably near term a lot more there's need to adopt even more practical, more basic AI in so many of these different areas. So I think there is a vision for that. I personally think that there's a lot of adoption for the more basic AI still to come in the near term.
So I agree. It's going to be an explosion of experiments and form factors. I personally am looking forward to the parrot that's perched on my shoulder. They have eyes. You know where they're looking, which, by the way, is a problem with the glasses, right? So there's a lot of advantages to parrots. And I do think that this whole business about where the trade-off is, where the data lives and who has access to it for what purposes, is really something that needs to be worked out sooner rather than later, because it's going to be a problem.
I had to giggle because I'm not sure if Ken was referring to it or not, but we did work on parrots, graphical parrots that did perch on your shoulder in the 90s. But I want to say that what's interesting to think about is that for decades, AI was defined as research on how do we solve this problem coming in? Solution. And over the last 15 years, it's been inspirational to see it's a whole idea of lifelong learning, actual technical methods, deep technologies and mechanisms for dealing with streams of problems and then updating with data over time in a lifelong way. There have been workshops and competitions on lifelong learning or learning over the lifespan of an agent. I think this is the year, by the way, the next year or two, we're going to see in the consumer side, all sorts of interesting memory and recall. There'll be interesting rough edges with that as well as systems, as commercial entities, as well as academic groups explore what does it mean to have rich memory of shared experiences with humans, and then leveraging that in interesting ways to make these systems better.
And just
So
as
here's a way to think about. Here's a way to think about one of the problems in cognitive architecture that's going to show up. So today's AI systems run a narrow line between catatonia and attention deficit disorder. Right? Humans are much more robust than that. And understanding how to make systems that now have substantial workloads that are interacting with people, learning about them, building models of them over time, and managing their own learning successfully without a professional going under the hood every day. That's a huge research challenge.
I was just going to add, we're also going to see a tremendous change at universities in how we educate students. They're already using these tools, ChatGPT, and I see them enormously positive. So they have 24/7 access to a knowledge source that they've never had. And so I encourage my students to use ChatGPT as much as possible in their own studies, and it's going to transform education.
Thank you so much. Kayvon Stassen.
Thank you very much for those presentations. I wanted to ask for your reflections on the relationship between AI and STEM workforce development, what on the board we often refer to as STEM talent development. And I'm not referring today about STEM workforce needs for the future of AI. That is a critically important question, of course. But I want to ask rather about the reverse, AI for STEM talent development. And I'll give you a quick example from my own work to maybe help inspire your reflections. At Vanderbilt, I direct a research center called the Center for Autism and Innovation in our School of Engineering. And one of the things that we're learning how to do is to leverage AI as a tool for seeing past what can be behavioral differences, social communication challenges, whether it's autism or attention deficit disorder, indeed. And then having the AI recognize the underlying talents and skills, and then learn how to match those individual talent and skills to appropriate educational opportunities and jobs. That's a very, very specific example, but maybe that'll give you a sense for the question that I'm asking. Thank you.
So I think there are tremendous opportunities for improving education, basically, for using these tools to individualize education. And your example is a beautiful one. How you can have really individualized educational objectives. And there's research going on of how to build such systems better, but the potential with the large language models to do this now and to actually take into account what the student currently knows, what the student, what kind of mistakes they made, what kind of deficits they have, and then give personalized attention to the student. The potential is tremendous there, and I actually would encourage to have more research investments in exploiting those new potentials.
So one of the problems we have is there's never enough people in education, right? And so as we get machines that are more socially capable and can build long-term memories of their interactions with people, which is something they don't do today, but build up long-term models and share those models across multiple people, then you're going to see another phase change. So already there's some great deployed systems. So for example, from our NSF Science of Learning Center, we have these things called sketch worksheets that instructors build, right? And for instance, the geoscientists have gone to town and they now have worksheets that cover an entire inter-geoscience class. And those give feedback anytime, anywhere to the student and assessment data for the instructor. So everybody wins.
I have to say that there's work cut out for us as a nation and the world when it comes to AI and harnessing it in education for the kinds of issues that were just brought up in the question. There's lots to be done. We can't assume that AI, these generative AI models will be this GPT chat style interface forever. Things are going to change dramatically. I think we have to keep in mind for every question coming today and every discussion and every reflection that we tend to think we are on a plateau now, that, oh, we've seen this inflection, we're on a plateau and we understand these technologies. Let's figure out, it's already complicated, how to integrate these new capabilities into education, healthcare, scientific discovery, and so on. But we have to realize we are surfing a wave that's changing dramatically as we surf it. Within 18 months, I'd love to come back to this panel and say, look at what we see now. And so we have have to get our creative juices flowing and track the technology and think deeply about partnering as scientists, as SBE, as Department of Education, with the practitioners, because we are in a revolutionary time when it comes to how these technologies are going to be interleaving with multiple sectors.
And one thing I would like to add as a use case that I'm particularly excited about is having these systems serve as teaching assistants. Frankly, in many of our universities, we do not have enough teaching assistants to help students, say, to learn computer science or to learn other fields. And the challenge is students can get frustrated if they can't get help, they can't find a person, the office hours don't align with their class schedule. And so having a teaching assistant, and some schools are already piloting these, say, for computer science, I think that's going to be able to help us scale so that we can teach more students in these areas and give them the kind of feedback, learning feedback that they need in order to become more skilled at what they're studying without needing as many human teaching assistants that we just don't have access to at the moment. So that's a use case I'm excited about.
18 months, that would be about the November 25 meeting. So we're making a mental note of that.
I would love to see everybody then.
Terrific. Anyway, in the meantime, Lynne, I was particularly taken by your comments about AI education and training and the assertion, which I agree with, that everybody must become AI literate. As you're probably aware, the Science Board, in collaboration with the National Center for Science and Engineering Statistics, publishes science and engineering indicators every year. And one of the more shocking sets of statistics in recent years has been the stagnation followed by the drop in the performance in math and science by U.S. students in K through 12. And we've been focusing on people who've run that gauntlet, and they're beyond that now. But as I'm thinking about the general broadly based literacy of K through 12 students, what competencies must be sort of mastered in order for students to move on to competency in AI? We've talked about how AI might be able to help them, but now we're talking about how they then become competent in AI at various levels, from PhD down to skilled technical workforce or even other professions.
I would say an important starting point is even before trying to create a broad workforce that can create new AI systems, is to create a broad workforce that is eager and willing to engage with the use of AI tools that they don't have to build, but they have to understand what these tools can do in whatever career path that there is. My belief is that a lot of the hyperbole that we hear right now and a lot of the public conversation is simply because of people being maybe afraid of AI or just have no concept as to what an AI tool could even do. And so I think a basic understanding of computation, of what an AI can and can't do at a high level, conceptual level, not programming, understanding the ways it can go wrong and ways that you can mitigate against concerns like bias and so forth. I think beginning with an intellectual understanding and having some experience with no code tools that give people some experience with seeing how a computer vision tool might work, or how a natural language processing tool might work and so forth. I think that fundamental just familiarity with what a computational system like an AI tool can and can't do and ways it can go wrong can help, I think, help people, workers in any discipline, to be able to be comfortable with leveraging these tools. And I think that's where we need to start. And unfortunately, I think we're far from having achieved that level of literacy at the moment.
Thank you. Suresh Garamella.
Thank you, Julia. So great panel. I do think we need to have a regular interaction with this group because this is a fast-changing world. I guess I hear so often that companies are so far ahead of universities in research in this area and in multiple other areas. I guess, how do you see that being solved, in particular at the higher end PhD level research? You know, we have a lot of, we've all computer science departments or data science departments in every college sort of bursting at the seams, but seems like less of them continuing on to PhD programs. So that being the seed corn for the future of research, I wanted your reflections both from those who are at universities and Eric about how you think we'd solve this. And if I'm permitted a second question and you want to reflect on that, I guess I think one of you mentioned ethics. It just seems like there's so much potential for misuse of AI. And I was wondering if you might want to comment on how we guard against that as well. Thank you.
If I can start on the AI education and the AI research in academia, I'm actually somewhat optimistic there. We see initiatives. To me, some of the most exciting initiatives right now are AI for science programs, or AI for science engineering program. We have a very large program at Cornell now where we draw scientists and postdoctoral fellows from biology, engineering, mathematics, physics, and we connect them to our AI expertise. So these various disciplines are very excited about these new opportunities. This is actually something that they might not be working purely on AI technology directly, but they're working on how can we use AI technology to accelerate scientific discovery in material science, for example. And that's something that universities can do in a very positive way. I'm sort of thinking, and it's a little different than industry level research. It's using AI in these other areas where we are already have departments that are extremely strong, have extremely good research groups. And this integration of AI work with actual science and engineering areas, I think, is an opportunity. And if we invest in those efforts more, it's actually at Cornell, the program is funded by the Smith Foundation. It's actually a private foundation. And it's actually somewhat odd that a private foundation has to have the biggest AI for science program in the US. That should really be a national initiative that is funded from the federal level. But right now it's privately funded, but it's very successful. And I think it's a tremendous opportunity for AI to flourish. And it's a little different than industry pushes the AI research further purely as a technology, but applying it to these other areas, including things like psychology and other sciences. It doesn't have to be only engineering or physics. So I think there are tremendous opportunities there, and I wish we would exploit those opportunities with federal funding and not have to rely on private funding.
And just to jump in on the question, look, I think the question resonates with the earlier discussion on the National AI Research Resource. I do think that a lot can be done with smaller clusters now in the sciences. In some places, in many places in the sciences, we're limited not by the resources, but the compute, but by data potentially, which is another thing we should talk about in terms of access and sharing on data sets. But limited by creativity and I see great work ahead. It's been really inspiring to see how much AI for science, we'll use that phrase right now, is going on across the world. It's just blossoming, and it's not critically dependent on large company style resources. Just keep that in mind. That doesn't mean, as I said earlier, that we won't have some surprises with some of the bigger needs to compute and opportunities there in conjunction with what's going on, for example, in the protein design space with diffusion modeling and so on. Some lighter weight methods that are showing incredible promise and some surprising results. So in some ways, we should continue the efforts, small and big. We should think when it comes to the need for new kinds of partnerships with industry and new kinds of federal funding on the bigger side of the needs. Again, lots of uncertainty, lots of promise on a variety of methods at different scales right now. And some of the remarkable recent work is showing the power of advances in AI with smaller amounts of resource. Although I think say that data continues to be an interesting challenge. Moving forward, again, I spent a day yesterday, a full day. I won't give you the details of the workshop, but biologists from all over the world talking about what they're doing and potential needs for sharing resources, setting goals that might bring teams together that don't have access necessarily to corporate resources to get great things done. And it's just amazing to see the breadth and depth of what's happening in the biosciences.
Okay, so let me answer the ethics part first. So one of the key things that's going to happen as you build collaborators is they have to be moral agents. They have to share our social norms. They have to share our moral norms. And those have to be guardrails because there is going to be adversarial training out there, right? You know that's going to happen. And so that's actually a very active area of research in AI right now. In terms of education, so one of the things that works sometimes, doesn't always work, is internships, right? So PhD students take the summer off and go work for companies, and sometimes that helps them get access to resources they wouldn't have otherwise. Other times it turns out to be a distraction, it's hit or miss, but nevertheless, you basically get a sense about the broader impacts of the sorts of stuff you're doing, and it can help ground research in ways that are otherwise hard to do.
And I'll mention that just yesterday, just this week, we saw one of the asks in the executive order on addressing biosecurity come to conclusion with at least the next step from National Security Council and OSTP on requirements on DNA synthesis screening. We need to stay on those kinds of potential rough edges and potential malevolent uses. I think it's just the start, and that's just one example in one area. But we basically need to be thinking about investments we need to make such that we could, in some ways, have permission to innovate at the frontiers while addressing potential concerns, either inadvertent outcomes or, again, the malicious uses of the powers.
Thank you very much. Dorota Brzezinska.
All right. Can you hear me? It's me. Oh, I'm sorry. Mute or not mute? If I know? Okay now. All right. Thank you so much for absolutely fascinating conversation. And I agree with Suresh. We need to stay in touch with you. One of the most recent volumes of the Chronicles of Higher Education is entitled Higher Education in 2035. And one of the calls there is really that the research needs radical restructuring. And of course, one of the driving factors of this is AI. So AI has a potential to unleash in productivity, but also in gains in R&D, and also change the nature of research. However, and I want to quote from the article, using data to generate more data leads to industrialization of digital culture and a serious problem for the production of knowledge in research. So the authors are calling for the immediate investment in explaining data culture, and I think you already addressed this to a large extent. However, there is a risk described in this article, and it says higher education is at risk of forgetting its mission of knowledge production in favor of applied data systems that produce results. I wonder if you agree with this statement, and if there is a risk, what is the opportunity to address it?
You know, recently the National Academy of Sciences hosted a meeting, and that will be leading to a PNAS report coming out shortly on protecting scientific integrity in the era of generative AI, with a set of principles. I was one of the co-authors, and I spent time deliberating with fellow colleagues in academia as well as industry and nonprofit organizations, and very interesting to think about what are all the issues coming with the potential changes to the scientific process, including attribution, transparency, understandability of what these models are doing, how to create new kinds of genuinely valuable hybrids with complementary computing tools that promote scientific advances, understandability, integrity, and learnings. I'm actually quite hopeful that, you know, as I said earlier, I see sometimes that we're almost limited by creativity right now, not by compute in many areas of the sciences when it comes to how to use these tools. But there's also responsibility on the model and AI tool creators, the AI research scientists, to address some of these issues about what is needed and what will work well with human AI collaborative experiences, whether it be in the sciences or other areas. There's much to be done there in terms of methodologies that really augment and enhance human cognition. I keep on using the phrase, we need to really be thinking as we move into the next couple of decades, how do we celebrate the primacy of human agency and human intellect? Because I think that's going to rise to the surface as really a principle we have to be thinking deeply about.
Yeah, if I can add briefly. So I'm actually somewhat optimistic here. I think the large language models have added a new dimension to the whole issue of interpretability and understanding. So you can ask your language model to explain whatever answer it provides. And of course, science is actually very good at checking explanations and making sure that in reasoning change, for example, in mathematical, but reasoning change or in modeling, using formal methods, we're very good at verifying reasoning. So I think actually it's a challenge how to make sure that we get reliable results. I think interpretability may actually become less of an issue with the new technologies, because we can ask for explanations, and if we don't accept explanations, I tell my students to use large language models to generate answers, but make sure that they can follow the argument that justifies the answer. So I think there's actually some opportunities there that I'm optimistic about.
So I see potential flourishing for the use of AI in the humanities more broadly, because as you can start having conversations that are more grounded in human conceptual structure, for example, how do metaphors work, right? So there's a lot of study of metaphors, and being able to understand how you process those and understand them and build up common ground with machines, right? That's going to be hard. So one of the things language models and current AI systems don't do automatically is uncover what's called tacit knowledge in psychology. And so that's the sort of knowledge that helps you provide skills in problem solving and reasoning, the sorts of things that help you evaluate hypotheses quickly. And that kind of knowledge is something that humans are going to have to work with machines to articulate. So just to actually bring them into our world is going to help us understand ourselves better.
But what a great question that was. They're all great questions, but so thanks for the questions.
Yeah, thank you for that. We have 2 more questions queued up. I think that will take us about to the end of our allotted time. So first is Merlin Theodore.
Thank you, Julia. Thank you for the great presentation. AI, I think, is definitely a cross-cutting technology. So I'm curious, and there's a lot of uncertainties associated with scaling of this technology. If you had the R&D investments today and the policies in place for scaling this initiative, what would be your top 2 areas? I imagine that it'll be different models from area to area. What would be, I guess, in a sense, your test beds for demonstrating the technology that it works, for garnering more interest, generating more R&D? And what are your concerns with the risk associated with those?
Yeah, that's a great question too. I'm actually thinking that there's a whole range. Of course, biology in health, it can make a tremendous difference to use these capabilities, but also in material science and better battery technology. So there's sort of short-term gains that are very promising and could use direct investments of AI methods. And then there's a longer term strategy, even in mathematics. We see now the first results that are partly generated by new creative mathematical ideas that come out of AI systems. So it's a whole range of areas, and it might actually, in my mind, what I see was the AI for Science initiatives, by investing it, by injecting it in different subdisciplines. It can be even ecology and very different fields. It's somewhat surprising, what it can do in the different fields. So to set in advance, this would be the area to concentrate on, and it may actually be better to actually have investment spread out in different disciplines and see where it can take that discipline.
Yeah, and thanks, Bart. Can I suggest that rather than concern about can we be on a trajectory where we can generate results that will garner interest, I think we already have just really impressive early glimmers and impressive results to show, for example, Congress and the American public what's possible. I just thinking right now, just a simple, I wouldn't say simple, but so recent impressive results like the Collins and Barzilay work on antibiotics. It wasn't just the discovery of a new antibiotic for drug-resistant infections. It was taking that pipeline and adding a new layer, and this gets back to the last question on understandability, to reveal a whole new process that for a whole new category of antibiotic that kind of, I'll put it in quotes, shorts out the electric potential across the membranes of bacteria. It's like, wow, we learned this via the AI pipelines. These examples, I think we need to, as a scientific community, as advisors to the nation, we need to pull these examples together that already are here. We're already on this trajectory. There'll be more coming, and to think about what it will take to communicate the opportunities ahead if people aren't convinced. They're quite, I think it's more gathering and communicating and collecting and observing what's going to be happening organically in the fields right now if we need to communicate the opportunities at the frontier.
So I think what I would do is double down on the Open Knowledge Network for Common Sense. And there's some ideas on how to do that in one of the papers I put into the board book. Basically, if you have AI for science, for instance, biologists working in particular areas, that's great. But what about all the stuff you need for AI systems to understand what the biologists already understand, their tacit knowledge, their existing common sense? So you can drive forward the common sense knowledge by the stuff that you need, for instance, if you're a member of the public, to understand those cool results that Eric just talked about. So in other words, the theme here is bring the machines into our world, right? And language is part of it, but it's not enough. It's not all the tacit stuff. It's not all the other stuff that we do.
So the domain that I would prioritize is AI for education, for many reasons. Educate everyone, hopefully, is touched by the education process, the education community. And by having exposure of these kind of AI tools to literally everyone, I think we can help it enhance the creation of that STEM workforce, the expertise across all sectors. It also has some neat characteristics in terms of what some others have talked about in terms of the teaming with people. Education is inherently a collaborative effort with humans. And so that helps us really dig into that AI as a tool, AI as a collaborator maybe, but AI that's also toward helping humans. And it also brings in some of the questions about the responsible use of AI, and some of the questions maybe around bias and inclusion and so forth. And so that will help us, I think, accelerate solutions in those areas that are so critical. So I think that's a domain that could really have a multiplicative effect across all of these other areas.
Yeah, and I realized I didn't answer the second part of the question on harms. Let me just say that it's so, again, inspiring to see how much interest there is in graduate level education and students in the responsible aspects and looking at the interface between technology and policy. We're seeing the rise of programs and interest, which I think could garner more funding, but just the organic, again, interest in the ecosystem right now of places where you'd see traditional straight computer science. Now people are really starting to think deeply about and being very interested and engaged with these questions about, well, if we have powerful biology systems, biological reasoning systems, how do we red team these systems? How do we protect ourselves from malevolent uses? And, is this a rich doctoral level? And then, of course, deeper long-term research areas.
We are at time. Dan, do we have time for this last question? Okay, so Marvi Matas Rodriguez, if you could keep your question brief, and if we could keep the answer brief, we won't be too late.
Keeping a question brief is always challenging for me, so I'll try to do my best. Okay, so, we have talked a lot about and have focused primarily on the uses of AI and the benefits and, what investments are best and so on, which is fascinating topic. I would like to focus on actually the human aspects of and the human dimension from an individual level to more of a society level, the collective level. So, and the premise is, we have basically accelerated innovation on AI, but can we, as human beings, adapt to AI as fast? And so the idea here is there's, a lot of effects from job loss to society's economic structure adaptation to effects in the environment, and the energy pool that requires to really have all of these tools, right? Can we adapt as fast? What are the biggest challenges that you see for that, human and society adaptation to AI, and what can we do about it?
Okay, very brief answers, please. One thought apiece, please.
Okay, augment, not replace. That's really the slogan a lot of us are implicitly working on.
And yeah, I would second that. I tell my students collaborate with an AI system, and once people see that it's a useful system to collaborate with, I think we'll get more to the positive aspects of AI.
I would say that we're in a revolutionary time. Looking back at where we are 100 years from now, there'll be a named period of time over the next 25 to 30 years. We have to realize that we are in control. We are guiding the technology, and it's in our hands to observe, watch, react, optimize. Overall, very optimistic.
Yeah, and I'll just say, young people are so much more tech savvy because they're growing up with these technologies. And I'm quite optimistic that we are raising a generation that's used to fast changes in technology. I keep coming back to education. I think if we have AI literacy across the board, then people will be more comfortable with these technologies. They will know what the the gaps, what the potential shortfalls are, and then we'll get creative people to help us solve those problems.
Well, Lynn, Ken, Bart, and Eric, thank you so much for taking your time to spend time with us today. Thank you for your thoughts to kick off the conversation. Obviously, we could have gone on for much longer, and we look forward to the possibility of having you back at a future point because this, as you say, this is moving so rapidly. And thank you to the board members for your wonderful questions that really got things going after the remarks. At this point, we will look forward to continuing the conversation in this and other emerging areas. And I'm pleased to turn the floor back over to Chair Dan Reed.
All right, thanks, Julia. Thank all four of you. Really appreciate it.